Ready? All right. Introduction? Okay. All right. All right. I don't know why you should care. Okay. Hey there. Welcome to Self. And somebody turn this up and I'm echoing back at myself. One moment. Okay. That's a lot better. My name is Joe Brockmeier, and thank you all for showing up for my talk. I'm going to talk about Linux containers today. I work for Red Hat, which is not obvious on the slide except from my email address. My Twitter username is JZB. I like it when people ask questions and interact on Twitter, and I know the Self folks really like it when people interact on Twitter and make people aware of Self. And if I understand, we're sort of competing with a leather festival or something for the same hashtag. So our hashtag is #self2015. So one thing I would like to incite or encourage the audience to do is thank one of the sponsors of Self on Twitter or some other social network of your choice. Some of the sponsors today, I will not remember them all, but OpenIT Citrix, Red Hat, Fedora, I believe Ubuntu is a sponsor. Jeremy, help me out. Okay, I do. Thank you. All right, so please thank the sponsors and be very nice to them, and volunteers. All right, so I work on a project currently called Project Atomic. I work in the open source and standards team, and the goal of Atomic is to run Linux containers, more specifically right now, Docker containers, very well, and do nothing else. That's basically the job of the Atomic host, is to run Linux containers and get out of the way, okay? So what I want to talk about today, I want to talk about what containerization is. I want to talk about Docker. I want to talk about container history a little bit. I want to talk about basics of Docker. Most of this talk is going to be focused on Docker. And I realize that I may have misled some folks with the title of the talk, because there is a project called LXC which bills itself as Linux containers. But that's just one flavor of container. And obviously Docker is currently sort of the most popular container. So that's what I'm going to spend most of the time talking about, is actually Docker. How many folks are actually using containers of some form right now? Okay, how many folks are using Docker? Pretty much the same hands. Who are using non-Docker containers? A couple folks. What are you using? LXC. Who else raised a hand for that? What are you using? LXC? Anybody using something not LXC? Anybody played with systemd nspawn? Couple folks, 1, 2. Okay, has anybody played with the Intel stuff that recently came out, the ClearOS stuff? Okay, that's kind of trying to meld virtualization and containers. So anyway, I'm also going to talk about deploying Docker containers, and then we will take questions. I like when people ask questions. Feel free to raise a hand during the talk, but if you come up to me after the talk with a question that is of broad interest, I will mock you. So don't make other people suffer. Go ahead, don't be shy, ask your questions so we can all benefit. Okay, so what is containerization? It is often described as lightweight virtualization. It is an operating system method for isolating processes, Linux systems. Basically, it lets you have a virtual environment for a process or an application so that it's isolated. It has its application and dependencies and doesn't have a full copy of the operating system running. So in other words, using Linux containers, especially things like Docker, I can run something that looks like Ubuntu on a Fedora machine. I can run something that looks like Fedora on an Ubuntu machine, all that sort of stuff. I can't run FreeBSD in a Linux container on one of these systems. I can't run Windows under a container. If you want to do that sort of thing, you still need to run a full hypervisor that's going to provide virtualization for hardware and everything. Okay, anybody not clear on that distinction? So the advantage for containers is basically that because you don't need all of the resources that you would need for virtualization, it is much more lightweight. You can get a lot more density on a host running Docker containers than you can on a system running the same applications under KVM, for example. It's not as robust isolation as you would get with virtualization. There's still some security concerns. How many folks have read any of Dan Walsh's stuff about containers don't contain? Okay. Dan Walsh, otherwise known as Mr. SE Linux. We all know and love SE Linux, right? That was not a lot of enthusiasm for SE Linux there. Dan has spent a lot of time working on Docker and sending patches upstream and working with the Docker community, trying to make containers a lot more secure. And I'm going to talk a little bit more about Docker security and also just the concept of, for the love of God, don't just download something from Docker Hub that you don't know where it came from. Unfortunately, I think that they've really encouraged this behavior of, I'm just going to do a Docker pull. Somebody has packaged this application and I've never heard of this person and I have no way of verifying this image is from them, but I'm going to go ahead and put it on my machine and run it and then be shocked when it roots me. So if you wouldn't install an RPM or a Debian package and give it root access to your system without knowing where that came from, don't do it with a Docker container. Don't do it with an LXC container or anything else. So anybody not familiar with Docker? Good. All right. So I don't have to spend a lot of time explaining that. It is buzzword compliant, which is the important thing, right? So why Docker? It is the closest thing we have to write once, run anywhere currently. It's one of the easiest ways to deploy applications and have the environment where it's deployed look like the environment where it was developed and get rid of the, it worked on my machine, it worked in test, packaging. You don't have to package things. One of the things I'm going to talk tomorrow about the future of software deployment, and I'm going to talk about packaging like RPMs and things like that. And people who are writing Java applications don't really like trying to tame them into RPMs. If you want to deploy something in a container, you don't have to. You don't have to package your Ruby gems as an RPM or a Debian package. You can simply put all those things into your container and ship the entire container. It's much faster, has less overhead. Yes, sir. That depends on your environment, right? And where you're getting it from. It depends a lot on the vendor and where your stuff is coming from. Oh, right. Sorry. Yeah, so this is one of the fun things of videotaping the talk for everybody remotely is it slows down the actual interaction with the audience. For those at home, basically the question was talk about patching and how do you recommend dealing with patching in a container? And unfortunately, the short answer is I don't have a good short answer for you. Right now, it really depends on the vendor where you're getting your application, whether it's homegrown, things like that. Red Hat is working really hard to try to come up with coherent ways to ship updated containers. I guess the most basic answer would be I wouldn't patch a running container. I would have your application written in such a way where you basically move the workload over to new containers with the new, you basically take those containers down and spin up new containers that have the patch version. And you build that in whatever way you deal with. But we're also working on ways to do container introspection so that for example, if you have containers running in production, what's in those containers, whether or not they're vulnerable to something like Heartbleed or whatever the heck is going around. Does that kind of answer your question? For the record, for those playing at home, he nodded yes. So, all right, thank you. Another nice thing about containers is that they're layered. And what I mean by this, you get to build on other people's work. Last year, I went to Flock in Prague, and we had some folks from Yahoo, and they were using containers in production. They had one team that did the base container. Then they had another team that did a customized build of Apache and layered that on the container that the other team was maintaining. So one team is just worrying about what's, sort of the base OS and libraries. Then somebody else comes along and they layer Apache on top of that, and whatever, you know, magic dust Yahoo applies when they compile and patch Apache for their environment. And then that goes on to people who are writing applications that depend on those. So they get to layer on top of that. And all of the teams at Yahoo that depend on the base container and the Apache container or Apache layer, they don't have to worry about those parts. So one team can focus on that, and then say 20 teams downstream of them can leverage on top of that. It's modular, and it makes dealing with legacy much, much easier. And what I mean by that is that, for example, right now we have a lot of customers, Red Hat has a lot of customers, and CentOS has a lot of users that are going from, you know, 6 to 7. And you can do a couple of things. If you need stuff that's in 7, but you don't want to touch the running systems, you can run Docker on RHEL 6 or CentOS 6 and then run something on top of that. Or vice versa. You can package up your application in a container based on CentOS 6 or RHEL 6 and then run that on top of 7. So that makes deploying legacy applications, if they are favorable to a containerized environment, makes it much easier to put out into production. You had a question, sir. Sure. So the question was basically, so I did mention you can use layered images, and I've also recommended against just grabbing random images. So is it foolish to use something like the CentOS base image? That's a good question. No, because you can go to Fedora, you can go to CentOS. You don't actually have to go to Docker Hub. You can grab the signed tarballs from the projects and grab those so that you know it came directly from them. So if you trust CentOS or Fedora, and I would imagine, but don't quote me on this, I would imagine Debian and Ubuntu and other projects do similar things. You can go to Docker Hub and they have what they call verified projects. But currently, if I'm not mistaken, they don't have signing and things in place yet. But eventually, signing is going to be part of that chain. So yes, I wouldn't just run any random thing. So if somebody has packaged up some OpenSSL thing and they're not from a trusted vendor, I wouldn't use that. But if, you know, there are certainly ways today to go and get a verified RHEL image or Fedora image or other things. So that's a good question. Thank you. So container history. This is not new stuff, even though Docker kind of hit the scene 2 years ago and everybody was like, Linux containers, that's amazing. We want to do this. Actually, the concepts behind containerization have been around for a long time. You know, the Chroot stuff goes back to 1982. FreeBSD jails became a thing in, I think, 1998. This is, by the way, based on about 20 minutes of research on Wikipedia and elsewhere. So if I have a date off by like a year, I'm sorry. Linux vServer, does anybody remember that one? That was a thing in 2001. I actually used to work with OpenVZ/Virtuoso in a hosting environment in 2004, 2005, and it was great stuff. But it was not as simple or as elegant as what they've come up with Docker. Same concept, but it wasn't as easy to use or to work with. LXC kind of came on the scene around 2008, and that's what Docker built on initially. Docker is only 2 years old, which is, you know, kind of amazing to consider the impact that that's had. But that's open source for you, right? You can go from basically a concept that people haven't really worked with to something the entire industry is talking about in 2 years. So right now, I want to go through some Docker basics. So for anybody here who's been doing a lot of work with Docker, this is going to be very kind of, you know, old news to you, and I apologize for that. For those of you who haven't worked with Docker, I hope that you'll walk out of the room with some operational knowledge of Docker and go home and play with it, because it's really, if you just read about it and you haven't touched it yet, it's going to seem a lot more complicated than it really is, okay? So pulling an image, you can automatically pull any image from the Docker Hub. Again, no verification, use at your own risk. You also have to specify a version, and you see up here on the slides, it's a little, might be a little hard to see, but there's a colon between like CentOS and CentOS 7 and Fedora and 21. Unfortunately, there is not a universal versioning that is, you know, across all images. So Fedora does Fedora and then 21 or latest or whatever, whereas CentOS decides to do CentOS 7 or I don't know what the convention is for, say, BusyBox or Ubuntu. But you want to be specific unless you want to download all of the images, because if you just leave off the trailing bit there, Docker will happily just grab all of those images so you have them available, okay? Once the image is on the system, it's very easy to run. Basically, you can run multiple images simultaneously. You can run multiple versions. You can run the same image 20 times. We're doing this off of a central laptop. All the speakers get the same laptop, so I had a demo when I first did this talk at ApacheCon where I spun up like 20 Fedora 21 instances running Apache so you could see them all spawn in about a minute and start running. But Docker run TI, you get an interactive version. Most Docker images are meant to be spun up in such a way where they run an application and you don't get a shell to them. They just start up Apache or they just start up MySQL or whatever the heck it is that they're running. But you can also spin up an interactive version, and I'll talk about that in a little bit, that you can use to create new layers on the image and then ship later. And then you can also, once an image has been started, Docker will give it a name, just like two random phrases stuck together with a underscore. So for example, if I kick off a version of Fedora and I don't specify a name for it, the one when I was doing this slide was Pensive Stallman. And, you know, so it might come up with something like unhappy, you know, Raymond or something. Any questions on that? Yeah, way in the back. For those at home, those on the home game, the comment in the back was that they blacklist the phrase "boring Wozniak" with the justification that Steve Wozniak is not boring, which I would agree with. He's not. I've never met the guy, but I hear he's entertaining. I would have a beer with him. Depending on the quality of the beer, there aren't many people I wouldn't have a beer with, though. So containers versus images. This is something that stumps a lot of people early on, is what's the difference between a container and an image? Is this clear to most folks in the room? So an image is a file system and everything at rest. It's basically like an ISO before it's installed on a system. An image is the software at rest. A container is the running instance with all of its file system namespace and networking information and all that. The interesting thing is it remains a container once it's stopped. Does that make sense? So basically it's an image until you actually spin it up and put it into use. It is a container after it has been spun up and given a name and all of the resources. Does that make sense? Okay. Image history. One of the nice things about Docker is you can actually see the history of the image, so that when you download something, depending on how they've generated that image, you should be able to maybe look at the history of how those layers were added on and what was done to that image. So you can see commits to the image. It won't show you the container history, so you can't go and look at the history of a container once it's been started up, but you should see the history of an image. And you can also inspect the image and look at low-level information about it. You can also build images yourself, and it's actually pretty easy. There are a couple of ways you can do this. You can do it interactively. In other words, you can have a base image, you can spin it up, you can make changes, you can save and commit those changes, and you can work with it that way. Or you can specify the stuff that you want to do to the image in a Docker file and have it be a repeatable process that anybody can use to build that image. So the assumption is, as we were talking about earlier, using a base image like CentOS, Fedora, whatever, from scratch, and you want to automate as much as possible. So interactively, you start with the base image, run Docker run, TI, etc. Do whatever stuff that you want. For example, if I wanted to do a CentOS image, I might spin up that image, log into it, and do an update so that I have the latest software. So maybe the image on Docker Hub or wherever you get it from hasn't applied the most recent updates. So you can do an update and then go ahead and commit it. And then you have an image with the latest updates to put out in production. And you can rinse and repeat that as necessary. Is that any questions on that? Okay. You can save or export the image. There are two different things. Export flattens the image into a tarball, and it doesn't provide the history. Saving will export the image to a tarball, but you will keep the history. So if you want to preserve the history for other people to see, you want to use save rather than export. Obviously, if you can export, you want to also be able to load the image. So there's the load or import commands. Docker load will take your tarball, restore all of the images and tags, whereas Docker import will give you a new and untagged image. Does that make sense? All clear? Yes, sir. I'm sorry, could you say again? No, it's one tarball, I believe. Yeah. So you can also export these to a registry so you're not pushing around tarballs. You can use the Docker Hub or you can use a local registry. My understanding from talking to people who are working with customers at Red Hat and people who are talking to more folks who are using like CentOS and whatever with containers is that very few businesses are using Docker Hub to get their containers. Most businesses are using, most organizations are using a local registry, which is fairly trivial to stand up. If you have an environment in which you are running many Docker containers, it's fairly trivial to stand up a registry of your own. So like Git, you just use push and pull to move content to the repo. I should have revised this, but this was originally given at ApacheCon, and I was raising the discussion whether Apache should have its own registry for Apache applications. So anybody think Apache should have its own registry? Does anybody care? Okay. I also want to note something. How many people have heard about patches that Red Hat has added to Docker that differ from upstream? One person. Really? Okay. It made a couple of folks at Docker a little bit cranky because it changes the behavior slightly. So the behavior for Red Hat and Fedora and CentOS Docker is slightly different than the behavior you would get from upstream, and here's why. We have tried to ship vanilla Docker as much as possible. We have tried to get these things upstream, but there is some disagreement in how these things should be implemented or how they should look, and we were not able to get the patches upstream in time for shipping with RHEL. So basically, we have added a couple of things. Number one, we point to the official RHEL registry for people to get things. We want people to be able to, on the Red Hat side, people who have RHEL subscriptions to be able to get RHEL, and we don't put RHEL up on the Docker Hub. So we point them to our registry, and there's the added benefit that they know the provenance of those images, okay? Docker search, we list the fully qualified name that comes with those images. And what I mean by that, when you do a Docker pull Fedora, the default behavior of Docker is I'm going to look at the Docker Hub and I'm going to grab an image named Fedora, okay? It doesn't show you the actual URL of the registry. And we want to make sure that people know it's a little more complex, but we want to make sure that in the enterprise, people know what registry they're bouncing off of. You had another question, sir. Yes. It is configurable. And so the question for those at home, do we provide a way to configure the default registry? And the answer to that is yes. It is configurable. We want it to be We want, if you want to point to the Docker hub, then you should be able to do that. If you want to point to your private registry first, you should be able to do that. Okay. We also have the ability to block registries. So for example, if you're in the DoD and you are deploying Docker containers, I'm pretty sure they don't want you to download anything from Docker Hub. They want stuff that they have looked over every bit before it's deployed anywhere. So they could block all registries except their officially approved ones. So also, nice little feature, we warn on push. We don't not let you do it, but we warn you when you're going to push to a public registry, because there's a very nice chance that somebody could put confidential information in a container and accidentally pull it up to the Docker registry where anybody could download it. That's generally considered bad, right? So we don't want people to do that. At least we don't want people to do that accidentally. If you want to push to the public hub, then you should be able to do that too. Any questions on that? All right. Getting started with Docker files. The great thing about this is that there are hundreds of thousands of Docker files in the wild that you can look at and learn off of. We have 2 repositories for CentOS and Fedora Docker files. All you have to do is go there and look. These aren't just the base Docker files. These are Docker files for applications like Nginx or OwnCloud and things like that. So, for example, how many people have ever tried to install OwnCloud? Okay, how many people found that a fun experience? Lot fewer hands. We have OwnCloud packaged as a Docker image that you can basically grab the Docker file, build it, and be running OwnCloud in about 5 minutes, depending on your network speed, maybe 10. Hotel, 15. So, but building an image is also fairly easy. It's a one-liner. And it's just boom. You run build rmt user app name and everything, and you're good. The trailing dot at the end is to say that the Docker file is in the current directory, by the way. So you could also point to a Docker file somewhere else. Creating Docker files, they're very simple or fairly complex depending on what you're going to do. My suggestion, this isn't a requirement, but my suggestion is you do 1 service per Docker file. Don't take an application like WordPress that you're going to put out in production and put everything into one container. The whole idea is microservices. So you want to abstract things out to where you have Nginx or HTTPD in one, you have Postgres or your database in another one. That also makes it easier to stand up and take down things for updates, okay? Basic format for a Docker container, you can basically add the from, maintainer, these are free form. Run commands are things that you're going to run in the container. You can add files into the container from your local machine, decide what directories, or I'm sorry, what ports you're going to expose the outside world. By default, these ports are not exposed, okay? And then commands that you run once the container is spun up. Okay, so the difference between run and command, for example, run is something that I'm running as I'm building the container. Command is what I want to run after the container is started. Okay. Is there a hand back there? Yes, sir. Question is the CMD run inside the container, inside the host? The CMD is run in the container. Yes, sir. Yes, that's port 80, and that's going to expose that to the local machine. Yes. No. If I understand your question correctly, you're asking if I expose port 80, is that going to make it the default port 80 for the machine? It is so it is not exposing it on the host. Yeah, it's only exposing, it's basically saying The host can point a port to talk to this, but it does not automatically do that until you run the container, and there's a separate port command to say, for example, you might map port 5024 to the container of port 80, but that is something you do when you run the container. Yes, sir. Yeah, you can. The question was, can you bridge static IPs to containers? And yeah, there are ways to do that. So Docker out-of-the-box networking is a little basic, but there are things like Weave and Flannel and other solutions that are trying to make, basically SDN for containers that are making it much, much more robust. And so the real question is, what is your environment? And are you using one of these things, or are you just using straight Docker and things like that? Networking isn't my strongest area, but it's definitely something that's doable. So yeah. Yes, sir. Oh, why I have the ampersand on the run command, or why am I doing the clean all? Basically, so you don't come up with two layers. Yeah. Sorry. So the question was, why am I running several commands? Everybody is familiar with the double ampersand convention. Okay. So why am I doing that with one run command instead of a run yum update and then a run yum clean all? The reason is each run command will generate its own layer. And so the reason I'm doing the yum clean all here is because I don't want to carry that cache in the image, because that's going to bloat the image. And if I do it in a separate run command, I'm still going to have that layer. So, yes, sir. The question is there a limit to the number of layers you can have? The answer is yes. And I think that it's currently 1024, but I could be lying depending on what changes they've made recently. But my latest reasonable information and my memory, which is, I'm not a young person anymore, 1024 is what my brain tells me is the limit. You've had a lot of questions, so I'm going to go to the green shirt fellow first. Uh-huh. I would be the wrong person to do that. I'm sorry. Yeah, it's been a long time since I put this presentation together, and I do not remember the difference. I'm sorry. You had a question. No, but the run command and things like that do. I'm sorry. Does every line add a new layer? No, not necessarily, but the run commands do. I don't. Lost a lid. I don't think so. Another question somewhere, or are we good? Yes, sir. Uh-huh. The files persistent. I'm sorry. The question is, how do you make the files persistent on the host? But do you mean the files to be persistent on the host or in the container? Yeah. Okay. So, so the question is, how do you keep the data on the host even if you remove the container? The way you would do that is mount a directory on the host as a volume. And so then it will just treat, remember, this is all running on the host as a process anyway. So you can basically point it to a directory on the host as one of the volumes. So you could, for example, point like var lib mysql at a directory on the host and leave those on the host, so that when that container is removed or even destroyed, those files will still be on your system. They won't be removed. So, other questions? Yes, sir. Mm-hmm. So the question is, how do you get microservices? So the question was, how do you get containers to talk if you're running microservices? And basically, you tell them that on the command line. You basically bridge them through Docker itself. Or you use services like Kubernetes, which is definitely outside the scope of the talk. But yes, sir. So the question is, can you take a running server or virtual machine and put it into a container? And the answer to that is, I'm sorry? Just the application. Right. So the question was, is there a process to just take an application from a server and put it into a container? The answer is there probably are tools to do that. That is not supported directly by Docker. I think that there are folks at Red Hat, for example, who are working on this, who are banging on that problem. I think it may be a feature for Fedora 23, a proposed feature to do server to container, but it's not part of Docker. It's something that other people would have to ship tools for. Follow-up question? Yeah. Mm-hmm. So question, well, I just want to point out that I now hate the people at home. No. So let me try to summarize that. Basically, he's wanting to show, he has a process for showing that he has patched something that's running in a virtual machine, which does not necessarily move over to containers right now. And he wants to be able to use containers, but be able to show and verify that he's patched the images that are running in production. Is that a fair summary?
Yes.
PCI DSS is what you said?
Yes, PCI DSS, and specifically that the virtual machine running the application is fully patched at this time. I can drop out Docker files and drop in images and out and bring the applications and pieces parts in and out. But as I drop them out and drop them in, I have to show that the ones I dropped in are from sources that have been fully patched.
So the answer to that is I am not aware of a way that you would do that. By the way, I want to take a picture of the audience before the talk is over. So everybody say containers.
Containers.
That was pitiful. Okay. So I am not aware of something that would solve that problem right now. I think that is at the point where you probably get a vendor involved of some sort and talk to them about it. I don't know that your tools wouldn't work with containers themselves, but yeah. I don't, off the top of my head, I work in community land, so I don't necessarily have a drop-in answer for that one. Question back there in the green. Oh, you have an answer. All right.
All right, I have an answer or suggestion for the gentleman who's wondering how to show the proof of patching of a container. If you're running a very fat container, one that actually has RPM or apt-get in it, you can do a query of the container saying, all right, what versions of RPMs, what versions of Apache if I'm running, prove that that I did patch it. I don't know if you'd want to, but you may go so far as to running some type of vulnerability scanner within the container. But another way to do that is if you do some extra work, you have a known good image on a host, you then start doing like MD5 sums or SHA-256 sums of the files, and then you simply say, all right, this is what a patch system looks like. Compare that to the container, and you crypto check some files. That should be good. So that's one option. It's not clean, it's not necessarily easy, but it's workable.
Any other questions? Project Atomic, thank you for asking. Project Atomic, I meant to talk about this at the beginning, but I was so excited to talk about containers, I didn't get into it. Project Atomic is the umbrella upstream project for Red Hat's work around containers. So it's a bit of an oddity as an open source project, because usually you have a project like Fedora, and Fedora produces the Fedora images and so forth, and you have like kind of one goal and you produce one thing at the end. Project Atomic is an umbrella project for all the work we're doing around containers. And so right now we produce patterns and software for working with atomic hosts, which are basically a streamlined host for running Linux containers. Fedora, CentOS, and Red Hat Enterprise Linux all produce atomic hosts, which are basically minimal images that run Docker containers, and they provide a couple of utilities that are necessary for running those containers, like Kubernetes and Flannel and etcd, and that's it. Everything else should be run as a container. My talk tomorrow, I'll talk about some of the ways that you deliver software for that, including things like super privileged containers and atomic apps. But Project Atomic also encompasses things like user bin atomic, which is a command that is used to update the host and to work with and install containers. There's also Nulecule, which is a specification for installing complex containerized applications, which includes information about how to run them with things like Kubernetes. So basically, it's almost like RPM or Yum for containerized applications. So you can run atomic install foo and get a running application that consists of several containers and Kubernetes orchestration information. It'll tell you how to set up your volumes and networking. All of this stuff is things that you don't have to do manually. We also have Atomic App, which is the implementation of Nulecule, and we have RPM OS tree, which is how you update atomic hosts. RPM OS tree takes, right now when you install Fedora or CentOS or whatever, you're installing something built from a bunch of RPMs, and then you continually update it as new RPMs. RPM OS tree is like Git for operating systems. Basically, it lets you update A to B. You install a new tree, you reboot, and you're into the new tree. And you can revert to the old tree if something goes wrong. Does that kind of cover your question? Any questions about that? By the way, that also reminds me, I have some shirts that I would like to throw at the audience. So let's see here. Who's a large? Who's a XL first, actually? Who's an XL who would like a shirt? All right. No problem. Another XL. Another XL. There we go. I meant to throw these out for questions, but the questions were just so enrapturing I completely forgot. Large. Who's a large? Rubber band probably would have helped. One more XL. All right. We have a couple at the Red Hat booth, by the way, too. So another XL. All right. Throw it on back there. There we go. All right. If you did not get a shirt, but you want a shirt, we have some more at the Red Hat booth, and I do not want to take any of them back. So please stop by. We also have a lot of atomic stickers. So if you would like an atomic sticker for your laptop, but if you are interested in containers, I really encourage you, run Fedora 22 or CentOS 7 or RHEL if you are a RHEL customer. Give them a shot. If you are interested in putting them in production and actually doing serious work with containerized apps, I would really strongly encourage you to look at Fedora 22 Atomic Host, or look at the CentOS rebuild we'll be putting out soon. Or again, if you're a Red Hat customer, the RHEL 7 Atomic Host. How much time have I got left? 15 minutes. So I have time for another question, or we can all go grab beers. Yes, sir, way in the back. This guy is anti-beer, I just want to point out. So the question is, and I hate these kind of questions, because they're very reductive. The question is, how does it compare to CoreOS? They're both operating systems. So how it compares to CoreOS, I honestly don't spend very much time looking at CoreOS, so I can't really say exactly feature parity here and there. So broadly speaking, CoreOS and Atomic have very similar goals. We want to be operating systems that are minimal for running containers, so we're not wasting any resources on anything unnecessary to running containers. We share a couple of things. We use etcd, for example, which the CoreOS folks have developed. Hooray, open source. They do work. We get to have that. We do work. They get to, you know, take some of that. It's all great. Clustering is not something that is currently part of Atomic, but that's something that probably will appear at some point. Any other questions? Yeah. Oh, sorry. I did want to add this part. So the other thing about Atomic and Atomic Host that's important to understand is that we could have gone and reinvented the wheel and started with a brand new from scratch operating system. But a lot of people happen to be running RHEL or Fedora or CentOS in their environment already, and we kind of figure that people don't want their, you know, a lot of people, for example, run CoreOS or Atomic in virtualization, right? So you've got to have an operating system down here to run that. And then you're going to be running containers, which are comprised of a different operating system, which is a layer that CoreOS doesn't provide. We are trying to provide the entire sandwich, whereas CoreOS is sort of this layer. And we are providing, you know, from the bare metal to the layer running the Docker to the Docker filling, basically. Okay. Other questions? Yes, sir. So the difference between Docker and LXC and Docker and Rocket. So Docker started out based on LXC. It just simplified the way that you deploy images and work with them. It's not only the engine to run the containers, but it's also an image format and a way of working with containers that's much more simple. Now, I haven't looked at LXC since Docker containers became a big deal. And so the LXC project may have moved farther than my understanding of it is currently. Rocket is an effort by the CoreOS folks, and we're trying to get it packaged in Fedora. They do some interesting things with repackaging base image and systemd that we're trying to get worked out in our packaging guidelines. But it solves or tries to solve some of the perceived security issues with Docker. So it's basically, it's very much like Docker. They're just trying to solve some of the things that they perceive as insecure with Docker, which I think some of our engineers tend to agree with. The problem is that Docker already has runaway adoption, and we want to kind of solve the problems in Docker before moving over to Rocket. So I'm noticing I'm talking with my hands a lot. That's weird, but anyway, I think Brian Prophet has rubbed off on me. Be sure to tell him that. I'll do the jazz hands. All right, I'll take one more question. One more. Who's got a really good question? This guy. You don't look very confident about it, by the way. You're kind of like, I might have a good question. The question is Atomic good for running KVM or just containers? So you could run KVM if you use a super privileged container to bring in libvirt and all of those things. It's not really designed for running KVM. If you want to run KVM, I would take a look at Overt, and we happen to have Brian Prophet out at the Red Hat booth, and he can talk to you about that. There's also some discussion, I think, about, for those of you who aren't familiar with the Overt project, it's basically a master and node configuration where basically you have one controller and then you have overt nodes that are basically similar concept to Atomic. They're slimmed down nodes, and the only thing they're really meant to do is run KVM containers. You're not meant to run anything on those hosts directly on the host. You're meant to run everything in containers. But that project, Brian Prophet can talk to you a lot more about. So we are talking with them about possibly using RPMOS tree for the overt nodes so that you would update those nodes, and Overt may eventually expand to managing containers and KVM. But that's future stuff that may or may not happen. So, all right, I'd like to thank everybody very much for your attention. Have a good rest of self.
Citrix Zen Server gives you everything you need to integrate, manage, and automate a virtual data center, all on an enterprise-class, cloud-proven virtual platform, and at a third of the cost of other solutions. But why even bother with virtualizing your server infrastructure in the first place? Well, let's say you have a traditional one server to one application architecture, but you're running out of resources and performance is suffering. Once you order new server hardware, you'll wait for delivery, configure it, install your business application, stage and test the server, and finally, add it to your production farm. If you've been through this process before, you know it can take weeks or even months. You also know it's a manually intensive process that will burden your team every time you outgrow your current setup. With a virtual server solution, you could accomplish all of that in less than half a day. Server virtualization software separates the OS and application from the underlying server hardware. And with multiple virtual machines on a single server, you can use each of them to run different OSs and applications. This makes it possible to move your virtual machines from one piece of hardware to another whenever you want, to maximize utilization, simplify maintenance, or recover from a hardware failure, and without slowing down your applications or users. Clearly, server virtualization provides big benefits, and Citrix Zen Server provides even more. Since it's built on an open platform, Zen Server plays well with your existing hardware, storage systems, and IT management software, as well as with the industry's leading cloud service providers. Best of all, you can get started by downloading a fully functional, production-ready version of Zen Server for free. After a 10-minute installation process, you'll see how easy it is to start virtualizing your workloads and automating your IT management processes. And when you're ready for a richer set of management tools, just upgrade to one of the premium editions of Zen Server. So whether you're interested in virtualizing servers for the first time, expanding your server virtualization footprint, or moving server workloads to the cloud, download and install Zen Server today and see how it can help you simplify your IT environment. Citrix Zen Server. Do more. Don't spend more.
Your customers rely on your website or application. If it's slow or non-responsive, it infuriates your users and costs you money. Keeping your business-critical systems humming along requires insight into what they're doing. Your system metrics tell stories that can reveal performance bottlenecks, resource limitations, and other problems. But how do you keep an eye on all of your system's performance metrics in real time and record this data for later analysis? Enter Longview, the new way to see what's really going on under the hood. The Longview dashboard lets you visualize the status of all your systems, providing you with a bird's-eye view of your entire fleet. You can sort by CPU, memory, swap, processes load, and network usage. Click a specific system to access its individual dashboard, then click and drag to zoom in on choke points and get more detail. Comprehensive network data, including inbound and outbound traffic, is available on the Network tab, and disk writes and free space on the Disks tab, while the Process Explorer displays usage statistics for individual processes. The System Info tab shows listening services, active connections, and available updates. Adding Longview to a system is easy. Just click the button, copy the one-line installation command, then run the command on your Linux system to complete the process. The agent will begin collecting data and sending it to Longview. Then the graphs start rolling. Use Longview to gain visibility into your servers, so when your website or app heats up, it stays up.